Hi everyone. In this video we'll go through second order derivative. That is, how do we achieve double differentiation? What is double differentiation? You differentiate twice. You differentiate twice and you'll get double derivative or second order derivative. Now let's take this example. Right? So what we will do, first of all, what are the notations for second order derivative? Either you can put it as, you can represent like this, or you can write it as d square y by dx square or f double dash x, right? Any of these ways you can denote second order derivative. We'll first find dy by dx, right? What is dy by dx of this? It is 3 into derivative of x cube is 3x square. Derivative of x square is 2x and derivative of 7 is 0. So I'll get 9x square plus 8x. This is first order derivative. Now I'll do second order derivative. So I'll differentiate again. So what I'll do? I'll differentiate again. So I'll get, now I'll write it as 2d square y by dx square. That is now 9. What is derivative of x square? It's 2x plus 8. Derivative of x is 1. So I'll get 18x plus 8. So this is second order derivative. Now let's take another simple example, right? So let's assume that this is equal to y log of log x. So what is dy by dx? See, I can write it as dy by dx, or I can write it as y1 or f dash of x, anything, right? So this would be log of log x. So it will be 1 by log x using chain rule, and derivative of log x is 1 by x. So it's 1 by x log x, right? Now I'll differentiate again. I'll differentiate again because I have to find second order derivative. So if I differentiate again, it will be, I can call it as d square y dx square, or I can write it as y2 or f double dash x. So now I'll have to differentiate this again. So 1 by x log x. So I can write this as 1 by x into 1 by log x, right? Two functions. So I have to find derivative of this entire thing. I'll have to use quotient rule. Quotient rule states denominator into derivative of numerator minus numerator into derivative of denominator by denominator square, right? Now what is denominator here? X log x, and derivative of numerator. What is there in the numerator? Only 1. What is derivative of 1? 0. Minus numerator. Numerator is 1 into derivative of denominator. Derivative of denominator, which is x log x, by denominator square. That is x log x the whole square. Instead of this, I'm writing y2. Derivative of 1 is 0. So this entire thing will become 0. Minus derivative of x log x. Now I'll have to apply product rule here, right? Because there are two functions. X log x. What is product rule? X into derivative of log x plus log x into derivative of first function, which is x. What is derivative of x? It's 1. By x log x the whole square. Now we'll simplify this. So we'll get minus, this will get cancelled. So I'll get minus 1 plus log x by x log x the whole square. This is nothing but minus 1 by x square into log x the whole square, and the numerator we have minus 1 minus log x. So this is the second order derivative of this function. Now let's take another example to show that this particular function is true, this particular expression is true. So we'll first differentiate y with respect to x. So we'll get dy by dx is equal to a is a constant, so we'll leave it like that. Cos of log x. What is derivative of cos? It is minus sign of log x, right? Now we'll have to apply chain rule. What is derivative of log x? 1 by x plus b into sine of log x. Sine is nothing but derivative of sine is cos. Cos of log x, and derivative of log x is 1 by x. So what do we get? We get minus a by x into sine of log x plus b by x into cos of log x. This is y1. Now we'll shift y this x this side. See, x is common here. So we can write this as, we'll take x as common here, 1 by x. So we'll get minus a sine log x plus b cos of log x. We can shift x this side. So if I shift x this side, I'll get x into y1 is equal to minus a sine of log x plus b cos of log x. Now we'll have to differentiate again. So here we'll have to apply product rule. So it will be x into derivative of y1, it will become y2. Second order derivative of y1 would be y2 plus y1 into derivative of x, which is 1, is equal to minus a, what is derivative of sine of log x? So it's going to be cos of log x, and derivative of log x is 1 by x, plus b, derivative of cos is minus sine of log x, and derivative of log x is 1 by x. So let me take x common. So I'll get minus a cos of log x minus b sine of log x. This is what I get, right? Now let me take minus outside. Let me take this minus outside. So you get minus 1 by x. I'll get a cos log x. If minus goes, I'll be left with plus, right? So I'll get this. Now notice what this is. This is nothing but y, right? If you notice, this is y. So we'll substitute y here. So if you substitute y, we'll get minus y by x. Now we'll shift x this side. So we'll get, this is in division, this will become multiplication. So it will be x into x y2 plus y1 is equal to minus y. We'll bring everything to one side. So it will become, first let's simplify this. It will be x square y2 plus x y1 plus, when you shift, this minus is going to become plus, is equal to 0. Did we prove this? Yes. So we've proven that this is equal to 0, which is equal to RHS, right? We'll consider this as LHS and this as RHS. So we got that this is equal to 0. So hence proved. Now let's take another example here, right? We have to show that second order derivative is 49 into y. So let's first differentiate first time with respect to x. So I'll get dy by dx is equal to 500 e to the power x, derivative of e to the power x is always e to the power x itself. So I'll get e to the power 7x. But there are two functions here, right? I have 7x also here. So what is derivative of 7x? It's 7. Similarly, 600 e to the power minus 7x is minus 7x itself. What is derivative of 7x? Minus 7x, it's minus 7. So this is nothing but 500 into 7 into the e to the power 7x minus 600 into 7 into e to the power minus 7x. Now I'll differentiate again to find the second order derivative, right? So this will be d square by dx square is equal to 500 into 7. I'll leave it like that. I'll not calculate this. We'll leave it to the end. E to the power 7x, derivative of e to the power 7x is e to the power 7x into 7. Similarly here, e to the power minus 7x is e to the power minus 7x, and derivative of minus 7x is minus 7, right? So d square y by dx square is equal to 500 into e to the power 7x into 49 minus and minus will become plus 600 into e to the power minus 7x into 49. Now I'll take 49 as common. So I'll get 49 into 500 into e to the power 7x plus 600 into e to the power minus 7x. Now what is this? If you notice this is y, right? This is y. So let's substitute y here. So you'll get 49 into y. So we have proved the derivative. 49y. We proved it. Let's take another problem here, right? So differentiate with respect to x. So we'll get dy by dx, or we can write it as y1 is equal to derivative of x is 1. Derivative of root is 1 by 2 root x square minus 1, because derivative of root x is 1 by 2 root x. So instead of x, I have x square minus 1. Apply the chain rule. What is derivative of x square? It's 2x. 2 and 2 will get cancelled. I'll have 1 plus x by root of x square minus 1. This is y1. Now I can take LCM, right? I can assume there is 1 here. I can take the LCM. LCM will be x square minus 1. To get this as LCM, I have to multiply denominator 1 with this one. That is, I have to multiply numerator x square minus 1. So I'll get x square minus 1, root of x square minus 1 plus, now to get this as LCM, I have to multiply this with 1, but not the denominator, I'll multiply with numerator. So I'll get x. So this is nothing but y1 is equal to x plus root of x square minus 1 by x square minus 1 root. Now you notice this and this, right? This is y. This entire thing is y. So I can write this as y by root of x square minus 1, correct? So let's rearrange this. I'll shift this one here. So I'll get y1 into root of x square minus 1 is equal to y. Now let me differentiate again. I have to apply product rule here, right? So I'll get y1 into derivative of root of x square minus 1 plus second function into derivative of first function, which is y1, and derivative of y would be y1, right? What is derivative of y? It will be dy by dx, right? Instead of dy by dx, I can write y1. So now y1 into derivative of root of x square minus 1 is 1 by 2 root x square minus 1, and derivative of x square is 2x plus root of x square minus 1, derivative of y1 is y2, and this is equal to y1. Now I'll cancel 2 and 2 here. So what do I get? I get x y1 by root of x square minus 1 plus root of x square minus 1 into y2 is equal to y1. Now we'll have to get it in this particular form, x square minus 1. Okay, let's take LCM here, right? We'll take LCM. So what will be the LCM? It will be root of x square minus 1, right? Now to get this as the LCM, I should multiply this with 1, but I'll multiply the numerator, right? So it will be x y1 plus, now to get this as LCM, I should multiply 1 with this much, this entire thing. That is, I multiply the numerator x square minus 1, right? So we have y2. This into this would be root of x square minus 1, the whole square, correct? This into this. This is equal to y1. Now the square root and square will get cancelled. I'll be left with xy1 plus y2 into x square minus 1 is equal to y1. I'll shift this here. So I'll into root of x square minus 1. So now I'll shift everything to one side. So I'll get xy plus y2 into x square minus y1 into root of x square minus 1, which is equal to 0. We have to prove this entire thing, right? So we have got xy1, we have got x square minus 1 into y2, we have got this one also. Only here there is a difference, right? So here it should be in the form of y, and we have y1. So what we will do, instead of y1, we will have to get it in the form of y. So what is y1? Let's see what y1 is. Y1 is this much. Basically y1 is nothing but y by root of x square minus 1, right? Y1 is y by, if I shift this here, root of x square minus 1. So instead of y1, I'll put y by root of x square minus 1, and then I already have this root of x square minus 1. Now what's going to happen? This and this will get cancelled, right? The remaining else I can copy. So I've got the final proof, right? Finally I've proved this. Let me rearrange this. Minus y is equal to 0. So I finally proved this. So with this, we've come to the end of this particular topic. If you've liked this video, do press a like and share it. Thank you.